Okay, Wildcats. Today we're looking at Friday, May 3rd, special right triangles on page 80. If you would, update your table of contents. Okay, now your table of contents are updated. Let's take a look at the notes. All right, special right triangles on page 80. So you have the right triangle with the right angle, and you have the angle theta. Now, this is the opposite side, the adjacent side, and the hypotenuse. So your trig functions are sine of theta is equal to the opposite over hypotenuse, cosine of theta is equal to adjacent over hypotenuse, and tangent of theta is equal to opposite over adjacent. Now, cosecant of theta is equal to the hypotenuse divided by opposite, and secant of theta is equal to hypotenuse over adjacent, and cotangent of theta is equal to adjacent over opposite. Okay, so update your notes for that portion. All right, now you have a 30, 60, 90 triangle where you have 30 and x is across from the side, x is across from 30, and x squared to 3 is across from 60, and 2x is across from 90. And then the 45, 90 triangle, you have 45, 45, so they're both across from x because they're the same, and x squared to 2 is across from 90. Okay, so if you would, update your notes. All right, now your notes are updated. Let's take a look at the examples. Page 80. Special right triangles and trigonometry functions. Find the values of sine, cosine, and tangent function for theta. Okay. Now, sine of theta is opposite over hypotenuse. So the opposite side is 15. Now, to find the hypotenuse, we're going to use Pythagorean theorem. Okay. So we know that 15 squared plus 36 squared equals, let's call this h squared. Okay. Now, you take the square root of both sides to solve for h. So, the square root of 15 squared plus 36 squared is 39. So, h is 39. Okay, so that's 15 divided by 39. But this can be reduced. 15 divided by 3 is 5, and 39 divided by 3 is 13. Okay, now cosine is adjacent over hypotenuse, so that's adjacent divided by hypotenuse, which is 36 divided by 39, which can be reduced to 12 divided by 13. Now, tangent is opposite over adjacent. So the opposite is 15, and the adjacent is 36, which reduces to be 5/12. Okay, go ahead and finish up example 1. All right, now let's take a look at example 2. Now, sine of theta is opposite over hypotenuse. So opposite is 16, and the hypotenuse is 34. And that reduces to be 8 divided by 17. Now, cosine is adjacent over hypotenuse. Well, we need to find the adjacent, so we're going to use Pythagorean theorem. So, we know that a squared plus 16 squared equals 34 squared. Okay, so we're going to subtract 16 squared and take the square root. So a is the square root of 34 squared minus 16 squared, which equals 30. So a equals 30. So that's 30 divided by 34, which is reduced to be 15 divided by 17. Okay. Now tangent of theta, let me brighten a little bit, there we go. All right, tangent of theta is opposite, so it's 16, so opposite over adjacent, so opposite 16, adjacent which is 30, so that's 8 divided by 15. All right, go ahead and finish up example 2. All right, now it says use the trigonometric functions to find the missing values. Okay, so we see that this is 30 degrees, so this has to be 60 degrees, so this is a 30, 60, 90. Because 30 plus 60 is 90, 90 plus 90 is 180, so you're 180. Okay, we know from our notes that 30 is across from x, 60 is across from x, square roots of 3, and 90 is across from 2x. Okay, so it looks like we know what's across from 90, so we can say that 2x is equal to 74. Divide both sides by 2, so x equals 37. Okay, so we know that this is 37. If this is 37, then we know that across from 60, it's 37 square roots of 3. All right, let's take a look at example 4. If this is 60 degrees, then we know this is 30 degrees. Okay, again, we know this is x, x square roots of 3, and 2x. Now let's see what we know. Well, it looks like we have what's across from 60, so that's 10. Okay, so we can say that x square root of 3 is equivalent to 10. Well, to solve for x, we're going to divide square roots of 3 by both sides. Well, anything divided by itself is 1, so x equals 10 divided by square root of 3. The problem is you can't leave a square root in the denominator, so you need to multiply 10 divided by square root of 3 times square root of 3 square root of 3. So you're left with 10 square roots of 3 divided by 3. So we just found x, which is 10 square roots of 3 divided by 3. And the reason we know that is because the square root of 3 times the square root of 3 is 3. So we have this 10 square roots of 3 divided by 3. Now y is across from 90, and that's 2 times x. So that's 20 square roots of 3 divided by 3. Okay, let's take a look at example 5. Okay, now 45, 45, 90 we know is x, x square roots of 2. So it looks like that the 90 is across from 7 square roots of 2, so we can say that x square root of 2 equals 7 square root of 2. Well, that's pretty simple. X equals 2. And since x and y are the same value, y equals 2. And I almost forgot, I didn't have to, but I'm going to fill in here. So this is 10 square root of 3 divided by 3. This is 10. This is 20 square root of 3 divided by 3. And then this is 37 37 square root of 3, and then this is 74. You don't actually have to fill in that portion, but I feel like we should fill that in. All right, so again, we know that this is x square root of 2. So we see here that this is 45 degrees, this is 45 degrees. Well, since that's across of that, we know that this is 3 square root of 2. That means this is 3 square root of 2, which makes this 3 square root of 2 times square root of 2, which that becomes 2 times 3, which is 6. So x is 3 square root of 2, and y is 6. All right, go ahead and finish up example 3, 4, 5, and 6. All right, let's take a look at example 7. So going back to trig functions, we know sine is opposite divided by hypotenuse. So then opposite of theta is 24 divided by, we don't know the hypotenuse, so we're going to use Pythagorean theorem. So we know that h squared equals 24 squared plus 70 squared. So h equals the square root of 24 squared plus 70 squared equals 74. So that's 24 divided by 74, which reduces to be 12 divided by 37. Okay, cosine is adjacent over hypotenuse, which is 70 divided by 74, which reduces to be 35 . Okay, and then tangent is opposite over adjacent. Opposite, which is 24, adjacent, which is 70, which reduces to be 12 divided by 35. Now, cosecant, secant, and cotangent are simple. They're just the reverses. So that's, if sine is opposite over hypotenuse, then cosecant is hypotenuse over adjacent, or opposite. So that's 37 divided by 12. Here, hypotenuse over adjacent, which is 37 divided by 35. And then adjacent over opposite, which is 35 divided by 12. Okay, now let's take a look at example 8. So sine is opposite over hypotenuse. We don't have the opposite, so we can use Pythagorean theorem. So let's call that. And I don't want to use O because O looks too much like a 0. So let's use B. So we know that B squared plus 9 squared equals 12 squared. So we subtract 9 squared, take the square root. So B equals the square root of 12 squared minus 9 squared, which equals the square root of 63. So that means opposite's the square root of 63 divided by the hypotenuse, which is 12. And then cosine is adjacent over hypotenuse. Adjacent is 9. Hypotenuse is 12. that reduces to be 3/4. So tangent is opposite over adjacent. Opposite being square root of 63 divided by 9. All right, cosecant is hypotenuse over opposite, which is 12 divided by square root of 63. Now, you can't leave the square root of 63 in the denominator, so let me take this work out here. Okay, and I'll use space here. So cosecant of theta equals 12, and I'm going to make a nice line all the way across because we're going to do a lot of problems. It was a terrible line. I'll try that again. Just going to have to be a not so good line. All right, so 12 divided by square root of 63. So we need to multiply that by the square root of 63 times the square root of 63. So that equals 12 square root of 63 divided by 63. Which reduces to be 4 square root of 63 divided by 21. Okay. So I'm kind of extending example 8 here. Okay. So now let's look at secant is hypotenuse over adjacent. Okay. Which is basically 4/3. So that was simple. And then cotangent is adjacent over opposite, which is 9. And actually, let's come. So there's your final answer. Let's come down here to do cotangent of theta. So we know it's 9 divided by square root of 63. So, but again, we need to multiply that by square root of 63 and square root of 63. So then that's 9 square root of 63 divided by 63. Which reduces to be the square root of 63 divided by 7. Okay, go ahead and finish up example 8. All right, now let's take a look at example 9. So, sine is opposite over hypotenuse. So, we have 12 divided by 35. I don't know, what did I do? Not 12. Sorry, I misread 21 as 12. That should be 21. Okay. Now, cosine is adjacent over hypotenuse. It got dark again somehow, I don't know. We don't know adjacent, so we're going to use, let's just call this b. So 21 squared plus b squared equals 35 squared. Well, subtract 21 squared, take the square root, so b equals the square root of 35 squared minus 21 squared. which equals 14. So that would be 14 divided by 35. And then tangent is opposite over adjacent. So opposite is 21. Adjacent is 14. Which can be reduced to 3/2. Okay, cosecant, real simple. So that's 35 divided by 21. Secant is hypotenuse over adjacent, which is 35 divided by 14. And cotangent is adjacent over opposite, which is 2/3. Okay, go ahead and finish up your examples, start working on your assignment, and have a wonderful Wildcat day.